So we're going to start with the next part of reshaping, which is reshape longer. And in order to do that, let me go ahead and open a data set. All right, so we're going to start off with reshaping longer using this data set here. I have the ID, which uniquely identifies a person, and here we've got the height measurements at 4 different times. Time 1, time 2 in the second column, height underscore 2, time 3 is the height measurement for the person with ID 1 at time 3, and height 4 is the height of the person in time 4. So what we're going to do is we're going to go under data sets and we're going to go to reshape longer. And when you reshape longer, let's go ahead and give it a new data set name, test1. And we tell it that we want a new variable for the repeated factor. Let's call it time. And time here corresponds to time 1, time 2, time 3, time 4. And let's say we want the reshaped values to be stored in a variable called height. Okay, we select the variables that we want reshaped. And I'm going to start simple and go ahead and reshape it. Okay, so now I get my new data set. And here I get my height. These are the measurements of height. And I see under time, I see height 1, height 2, height 3, height 4, which is not really what I want. I'd rather see time 1, 2, 3, 4, and I'll show you how to get that. Now, in order to do that, we need to introduce a new special variable called, or keyword rather, called dot value. So going back to our example, we had a separate variable for height at time 1, height at time 2, height at time 3, height at time 4. And what we wanted, instead of having to do that extra step of recode, we wanted to create a column, let's say, with all the measurements for height and another column for the time at time 1, time 2, time 3, time 4. Now you can do that, but you need to use this new keyword dot value. All right, so we want to break up each of these 4 variables, height at time 1, height at time 2, height at time 3, into 2 variables. The first variable holds the value. Okay, so that's a special keyword that you need to specify. And the second variable is time. All right, and then you need to specify how you break it up. So how do you break each of these column names up here? You use a separator underscore. Okay, so once you specify that, and I'll show you how to do that using the dialog, what you get is this new data set here with the column name height. I've shown you equal to height here, but you'll have a column name height, and you will have another column name time. And effectively, the keyword value not only tells you that the values go here, but it also tells you that the name comes from the first part of the separator. Because you put value first and followed it by time, value tells you all the values of these cells go into this column, but also the name of the column comes with the first part before the underscore. All right, so let's go ahead and see how this looks like in practice. I'll go back to the reshape column 1 longer data set. Again, all these data sets can be found in the reshape longer folder. And let me go to data sets and let me bring up reshape longer, and let's create a new data set for the results. Let's call it test2. I will say now the variable names for the new repeated factor. Okay, so I'm going to give it 2 variable names here. Okay, I'm going to give it value and I'm going to give it time. Okay, and I'm not going to specify a name for the repeated value. And the reason is I'm using the special keyword up here, which will say to create a new variable with the value. And I must, whenever I specify multiple variable names here, and you see this note, whenever specifying multiple variable names that store repeated factors, I need to separate it by comma, okay? And I must also click advanced to specify how the variable names get created. So under advanced, what I'm going to say is I'm going to specify underscore here to use as a separator. Okay, now again, let me put in these variables I want to reshape. Let's not forget to do that. So as soon as I've put them in, I've told the I've told R that I want to create two variable names. The first variable name has the special value keyword which tells R to store all the values in each of these four variables here. And then using the separator underscore, it's going to break up these names. And the second part is going to be a normal variable name time, which will store 1, 2, 3, 4. Okay, so let's go ahead and run it and let's see whether test 2 looks like what we expected to do. And it absolutely does. So here's a time which takes the repeated factor. That's 1, 2, 3, 4, 1, 2, 3, 4. You have ID, which is your subject. So you're measuring person 1 at time 1, person 1 at time 2, person 1 at time 3, and you've got all the measures here in height. So it's exactly what you wanted. All right, so you remembered we introduced the keyword value and we saw how that special keyword value, when specified, stored all the column, stored all the values for height at time 1, time 2, time 3 into a single column. And the second was a normal repeated factor. So value was a special keyword and it created a new variable, and all the values for these repeated measures at time 1, time through got stored in the single column. Now the beauty of value is that it automatically doesn't just apply to one variable like height, it can apply to n variables. And let's take a look at that in the next slide. And here I have height, I have at time 1, time through, I have weight, I have triglycerides, I have blood sugar. There are too many variables to show. And the beauty of value is it automatically will take all the values from the n variables that you have in your data set, as long as you've selected those n variables, and it will create separate columns, one for height, one for weight, one for triglycerides and blood sugar, and the other variable that you specify, time, which is not using a special keyword, becomes your repeated column. And again, you need to specify how to break it up. So let's go and see how this looks like in practice. All right, so I'm back to the Reshape longer data set. And just to refresh really quickly, it got height at time 1 as a separate column, right up to height at time 2, weight at time 1, right up to time 4, and so on. And now I want to go back into Reshape and I want to go to longer and I want to give it a new data set. I'll call it test data set 4, and I'll enter the variable name for the new repeated factor. Okay, I'll use the special keyword value. Remember, when you use a special keyword value, you don't have to specify a variable name for your repeated value. Okay, so I'll just specify that here. And then I will say I want time. Okay, and what I'm going to do now is select all the variables I want to reshape. Okay, and these variables are reshaped into one or more variables. Again, value is really smart. It knows how to grab all the values for height and store them in a variable called height. It knows how to grab all the value for weight and store the values for weight at time 1, time 2, time 3 in a separate variable. The same with blood sugar and triglycerides. Remember, when you specify more than one variable here, you must separate it by comma, and I've got two variables and I need to give it the separator. The separator is underscore. And let's go ahead and run it. And let's look at test 4, and that's exactly how I want it. So I have the ID of every patient here, and I get time 1, time 2, time 3, time 4. I get their heights, their weights, and their blood sugar and triglycerides in separate columns. All right, let's go and make things a little more complicated. Let's open up the measurements across days and weeks for a single measure. I believe it's blood sugar in this case. And here you see for subject with an ID 101, I have blood sugar on week 1, day 1, blood sugar measure on week 1, day 2, blood sugar measure on week 1, day 3. Basically, there's one more repeated factor here. That's basically 1 week and 1 day, and blood sugar at week 2, day 6, rather week 2, day 1, right up to day 7, week right up to week 4. So we go from week 1, week 2, week 3, all the way to week 4. And for each week, we have 7 separate measurements for each day. So with that, let's go to data sets and let's go and make this longer. It's in the wider format right now. And let's go ahead and select the variables we want to reshape. I have selected all of them. Let's call this test 6, or rather test 5, and let me specify dot value here. And value is smart enough to detect that there's a single measure blood sugar. So you're not measuring multiple things, and it'll create one variable for blood sugar. And we want one for time, which is a regular or rather one for week, which is a regular repeated factor, and one for day. Okay, so that's here. And then we don't need to specify a repeated value because I'm using the special keyword here. The values will automatically be stored in the new variable that it'll create, and it'll look at the first value here to create the new variable as we talked about, and the separator for the variable names is underscore. I think that should be sufficient. I will go ahead and run it, and here I see I've got the results correctly. I've got my subject, week 1, day 1, I've got blood sugar. My subject again, week 1, day 2, I've got his blood sugar measures, and the same for the second subject for each day of the 4 weeks. Let's go ahead and create one more, take one more example. And here I have measurements across 2 repeated measures, day and week. But I'm not only measuring blood sugar now, I'm measuring sodium, and I'm measuring calcium as well. So let's go and hit reshape longer, and I will create a new data set named test 6. Again, I want to use the special keyword value because I want all the values in each of the existing columns to go into separate columns by virtue of what I'm measuring. So one column for blood sugar, one column for sodium, and one column for calcium. And I want a regular repeated factor for week and a regular repeated factor for day. So I'm using the special keyword value for the first new variable. I don't need to specify a count. I select all these variables I want to reshape. And I go ahead and specify my separator, which is used to separate these variable names, and I should be good to go. So you should see the results here. I've got my subject, week 1, day 1, I've got the blood sugar, sodium, and calcium, and I have that all the way for week 7, and then I move to week 2. All right, let's go and take an example of pivot longer or reshape to a longer format using a different separator. So I'm going to open up the data set here that I have reshape longer using a dot or period as the separator character. And here you see I have uh, height measurements at time 1, time 2, time 3, time 4, weight measurements at time 1, time 2, time 3, time 4, blood sugar. But the separator in this variable now is a period or a dot. Now, a period is a little different, okay, and let me show you how this is done. Again, I'll go under data, I'll go into reshape, I will go into longer, and much of it remains the same. So I'll enter a data set name, let's call it test 7. I will say the variable names for repeated factors. Again, I'll use the special keyword value because I want to store the values in separate columns or variable names for height, weight, and blood sugar, and so on. So I will say my factor variable happens to be time, and that is the second part of my variable name. And I'm not going to specify a count because I'm going to use the special keyword value. I'm going to go ahead and select all the columns I want to reshape. And as soon as I have more than one variable specified here, I'm going to go on advanced. Now, typically you would have just put a period in the as the separator here. I'll talk about option 1 in an upcoming, further on during this video. But just specifying a period is not going to be sufficient because what you have to specify here is a regular expression. Now, underscore is fine, okay, that's not a problem, but period is a special character within a regular expression, and you need to escape it appropriately. So do remember that if your separator is a period, you have to do the 2 backticks before the period, and stay tuned for later in this video. I'll talk about regular expressions in a little more detail. So as soon as I've done that, that should be sufficient. The point of creating this video is just to show you that if your separator is a period like it is here, clearly you see the period, you want to escape it. And you can go ahead and run it, and you will see that you will have your time, which is your factor variable, which measures height, weight, and blood sugar times 1, time 2, time 3, time 4 for each subject. All right, so we're setting the stage for why you need to know a little bit about regular expressions. So when you use pivot longer and you are creating more than one variable, so I'm sure you remember in the prior examples, we would specify the variable names here, and if there were multiple variable names, you'd separate it by comma. You would need to specify your regular expression, and in all the examples before, we were just specifying a separator that would help you extract values from the variables that were being reshaped. And the examples were easy because an underscore or a period would suffice as a separator. However, for more complex examples, you will have to specify the pattern you want to extract from the variables being reshaped within parentheses, which is in turn within your regular expression that maps the variable names. So it's kind of complex for you to understand, but hang on a little bit. Basically, what we're trying to get at is the pattern that you need to specify needs to be within the brackets, which is in turn within a regular expression that matches the variable name. So just hold on a moment and it'll be fairly straightforward. So a little bit about regular expressions. A regular expression is a sequence of characters that define a search pattern to match within a string. And in this example, the patterns that we're going to describe are going to match the variable names that you're going to reshape. Definitely encourage you to read some more. This is a very useful resource, but definitely let's continue to proceed with discussing this at a high level. So when you define regular expressions, you have quantifiers, And quantifiers are special characters that allow you to specify criteria. So for instance, if you see an asterisk, what that means is an asterisk in a regular expression means match the prior character or the prior block of characters at least 0 times. And you'll see this in an example. Again, the plus matches the prior character or block of characters at least 1 times, and the question mark matches the prior character or block of characters at most 1 time. So that means exactly 1 time. Okay. So another thing you need to be aware of, and again, this will be clearer in a little bit, is you have character classes or character classes that specify entire classes of characters. So what is a class of characters? It could be numbers, it could be letters, and there's several other examples. And how do you express that within a regular expression? There are two flavors of character classes. One is to use the square brackets followed by colon, followed by a predefined name, followed by another semicolon, and followed by the close of the square bracket. You can also use slash and a special character to define these character classes. So what's a character class? Let's say digits. So if you want to look for a digit, this is how you denote it in a regular expression. You've got the square bracket followed by semicolon, followed by, or rather this is a colon, followed by a digit, followed by another colon, and then followed by a square close of the square bracket, or you can specify slash d, d being a special character within a regular expression. Okay, and that would look for a digit. Can also be specified with the square bracket 0-9. Okay, so there are multiple ways you can specify something like looking for a digit. In the same way, looking for non-digits can be specified with the special character capital D slash D, and this can also be specified with the square brackets followed by the caret 0-9. So you're saying any character that is not a number from 0 to 9. Okay, again, lower here within the square brackets and the colon is lowercase letters, which is also can be specified as A-Z followed by square brackets. And by default, the dot within a regular expression matches any character. Okay, so a dot again is a special character, or it has special meaning within a regular expression, and a dot matches any character. So let's take some simple examples. The pattern AC asterisk B can be used to match each element of a variable name that starts with A, that's followed by 0 or more C's, followed by B. Okay, so the following will be returned by this regular expression pattern. It would return AB, ACB, or ACCB, or it would return all the variable names that conform to this match, and the following would not be returned. So if you had a variable name BA, it would not be returned because it doesn't start with A. If you had a variable name ZA, it would not be returned. Okay, now again, taking another example, AC followed by the plus, which is a special character, followed by a B, can be used to match a character or variable name that starts with A, the character A, followed by 1 or more C's, okay, and followed by B. So the following would be returned. Variable name such as ACB would be returned, variable name ACCCB would be returned, and the following would not be returned. BA would not be a match, ZA would not be a match because it doesn't start with A. Let's take a more complex pattern. Here we will use the special character period, and what we're saying is one or more, so a period, let's say a period represents any character, so 0 or more characters. Okay, the period here, as I said, does not represent a dot, it represents any character. The asterisk represents 0 or more, so 0 or more of any character followed by underscore is what we're looking for. And it would return, as an example, it would return ABC underscore. It would return 123 underscore because these are any characters followed by underscore. It would return underscore itself because 0 characters followed by underscore is what is specified here. And it would not return AB or ABC because AB and ABC don't have underscore in the string or variable name or character vector. Okay, and here I use character vector and string interchangeably. So here's a more complicated pattern. Now you do see a period here or a dot, but the period is, and as you know, a period in a regular expression means any character. However, when I escape it by two backslashes, what you're effectively telling R is don't look for any character, look just for the period. Okay, so escaping the special character dot means look for the period and do not use the normal meaning of the dot to mean any character. So specifically here, we're looking for variable names that must start with a period followed by zero or more underscores because I have the asterisk here. That means zero or more of the prior character underscores followed by zero or more dots. Okay, so the following would be returned as matches dot underscore ABC, dot underscore 123, because here I'm looking for, after the underscore, I'm looking for any character sequence, zero or more of any characters. Okay, and the following would not be returned, AB and ABC would not be returned because they clearly do not start with a period. Okay, so just recapping again what we saw in the prior videos and examples I gave you is we did specify an underscore and a period to use as a separator. An underscore is a valid regular expression. If I just put a period here, it would be a valid regular expression, but it would look for any character, which I don't want since I wanted to use specifically the period as a separator. As you saw in the examples, we had to escape the period because I said period is a special R, a special quantifier within a regular expression. And if you specify period by itself, it would match any character, which wouldn't work. But if you escape it, it will look for a period as a separator. So I hope that made a little more sense. And now for the more complex examples, you will have to specify the pattern you want to extract to form the variable names in parentheses, which is in turn within a regular expression. Okay, and so you specify a regular expression that matches all the variables you want to reshape, and within that variable expression, in parentheses, you specify the paths to extract to form the new variable names. Again, it's a little complicated, but hang in there and it'll make sense. So let's take a look at this data set that has several measures for different subjects. Starting at column 5, I've got up to column 37 represented. So the first column is new underscore SP underscore M 014, and column number 37 is new underscore EP underscore M 4554. Now, each of these variables contain, let's say, a diagnostic code to describe how the case was diagnosed. And this diagnostic code appears after the first underscore. Okay, so SP is a diagnostic code, SN here is a diagnostic code. So after the second underscore, you have the gender of the patient. So here M represents male, and if I scroll down to the bottom, F represents female. And after the gender, I have the age range. So 0 to 14, 15 to 27. In the first row, the subject is from 0 to 14 years. Rather, this is not the first row. This is in the fifth column. The subject or the measure is for a patient from 0 to 14 years of age, and in the second column, it represents 15 to 24 years of age. All right, so that's the age range. Now, clearly, again, let me reiterate, the new underscore doesn't mean anything. That's just a prefix that needs to be ignored. Then you have the diagnostic code here, which can take any of these four values. Then I have an underscore, which is followed by the gender, and the gender can be male or female. It can take one of these two values here, followed by the age range. which can take any of these ranges. Okay, so these are my variables, and encoded in these variable names, I have this important information that I want to separate out into separate variables. Now, clearly, underscore will not work as a separator, and the reason is very simple. Between your gender and age range, there is no underscore. So yes, between let's say the diagnostic code is prefixed, or there's an underscore before the diagnostic code and after the diagnostic code, but there is no underscore between gender and the age range. Okay, so just to make it crystal clear, I have this information here. Again, this is the format of each of my variables that I want to reshape, where I want the prefix to be ignored. I want to extract the diagnostic code in a separate variable. I want to extract the gender in a separate variable, and I want to extract the age range in a separate variable. So the first thing I need to do is I need to define a regular expression that matches all the variable names that I showed you in the prior slide that I want to reshape. Okay, parts of these variable names that get extracted to become new column names or new variable names again need to be enclosed in parentheses, or the curly C brackets or whatever you call it in the regular expression. Okay, since we're creating three new variables, one for the diagnostic code, one for the gender, and one for the age group, you would naturally require the brackets to appear three times within the regular expression. Okay, so let's take a look at the regular expression. Here I clearly have new followed by underscore. The question mark here says new followed by a single underscore. That's what I'm looking to match. Followed by zero or more characters, okay, which is my diagnostic code, which is again followed by an underscore. Okay, and that in turn is followed by a single character here. Okay, the single character matches the gender, and it is followed by zero or more characters which match the age. Now, I could be more specific here and say zero or more digits, but I've just left it simple. So this regular expression correctly matches the variables I want to reshape, and then I put in parentheses here the parts of this regular expression that I want to extract into separate variables. Okay, so it's as straightforward as that. Uh, get your regular expression that allows you to match the variable names, and then specify the parts of those variable names that you want to extract that become the new variables. All right, so let's go ahead and see this in action. Let me open up the who.r data dataset that's in the reshape longer folder. And you'll see in the variables that we just spoke about, there's new underscore sp underscore m 014 and so on. I will go under reshape longer, and let's save the results to a new data set. Let's call it test 8. Let's enter the names of the variables we want to create. Actually, let's just go ahead and select the variables that we want to reshape first. I want to reshape all the way to this last variable, which has the new underscore. These are the variables that are going to get reshaped. I'm going to create three variables. The first is with the diagnosis code, followed by the gender, followed by the age group. All right. And I want all the measures to go into this count variable, and or let's call it a measure. And now I'm going to go under advanced. Remember, when I have more than one variable here, I want to go and specify the regular expression that will help me extract the values for the new variables from the names of the variables being reshaped. I will enter the regular expression. Remember, the parts within the parentheses are the parts that are going to be extracted to form new variable names. And that should be it. Let me go ahead and run it. And here I have my new data set, test 8. There were a lot of NAs in the data, so I think I have to scroll all the way to the bottom to see the measures. And here you see the measures accurately reflected. Okay, so do remember that with this data set, you will have a lot of measures that are empty because you don't have values. With that, I'd like to thank you for your time and don't hesitate to email us if you have any questions.